Okay, this is the first module for Algebra 2 for the e-learning curriculum, Day 1. The notes for today support your textbook, Section 10-1, and these are the notes. You can either take the notes yourself on a separate piece of paper or print off the pre-made notes that were before this in the bundle. Targets today, you're going to be able to identify and graph conic sections. Conic sections, there are 4 types you should have seen in the intro video. They are circles, ellipses, parabolas, and hyperbolas. And then the second target is to be able to identify the domain and range of a conic section. This is Mr. Schrammick, and I'm here with Ms. Grody, and we're going to go over the first 4 conic sections. First, here's the definition of a conic section. A conic section is a curve formed by the intersection of a plane and a double cone. Is a curve formed by the intersection of a plane and a double cone. All right, the first conic section, if you look at the picture, is a circle. All right, a circle is when you're parallel to the top and bottom of the cone. The parabola exists when you're parallel to one side of the cone. An ellipse is kind of like the circle, but it's got some tilt to it. The ellipse can be either more circular or more oval shaped, depending on how you bend that conic section. And this is a new one for most students. This is called a hyperbola. The hyperbola is kind of like a double parabola, one facing up and one facing down. We're going to graph each one of these right now.
Okay, we're going to start out here with graphing a circle, and you're going to see the general form here of the equation of a circle, which is going to be x squared plus y squared equal to the radius squared. So what we want to start out and do is actually find the x and y intercepts here. So what I'm going to do, if you guys maybe remember this from Algebra 1, if I want to find my x-intercepts, what I'm going to do, I'm just going to cover up this part with the y squared, set that equal to 0 is what I'm doing when I cover that up. And if I do that, I'm going to solve this tiny little equation here by taking square root of both sides. So my x-intercepts are going to be 4 and -4. Remember, when you take a square root, you want to put the plus and minus in front of that. So I'm just going to go ahead and plot those 2 lovely points on the graph. There's 4, 0 and -4, 0. And then we're going to do the same thing with the y. Same concept. If I want the y-intercept, we're going to cover up the x, which is like putting it equal to 0, because that's where it's going to cross your y-axis. So it's going to be exactly the same thing. We got y squared equals 16. So when you take your square root there, you can get plus and minus 4 again. So I'm going to plot those points. I got 0, 4 and 0, -4. And this is going to go ahead and give me kind of the outline of my circle. I'm just going to kind of connect these. The center is going to be the origin at 0, 0. I'm just doing my best to make that a curved shape. Now, when we're talking about domain and range here, domain, that's how your x values change. So I know I didn't do a perfect job right there, but my x values start here at -4, and then we move over to 4. There's no graph to the right of this, no graph to the left of that. So the way I want to write that, I'm going to say -4 less than or equal to x less than or equal to 4, because I'm talking about x-axis with my domain. Now I'm going to switch to my range. How do I move up and down on the graph? So my lowest point here is -4, and it goes up to +4. So nothing above that, nothing below that. We're going to do our range. It's going to look exactly the same. -4 less than or equal to y this time, since I'm talking about how I'm going on the y-axis for the range, and then less than or equal to +4.
All right, so that first circle's been done. The second example is another circle, a little bit different form. If you notice this one, I've got a couple coefficients on the x and y, but we're going to follow the same procedure that Miss Grody showed a second ago. To find the x-intercepts, I'm going to cover up the y, and that's going to read 2x squared equals 50. So the only extra step I'm going to have is dividing both sides by 2, which leaves us with x squared equals 25. All right, Square root both sides of that, your x and y intercepts are going to be at positive and negative 5. X equals positive and negative 5. So my two intercepts, I'm going to go left 5. There's my leftmost point of my circle. And then I'm going to go right 5. That's my rightmost point of my circle. For the other intercept, I'm going to cover up the x term. That's the same as putting 0 in, making it an intercept. We're going to get 2y squared equals 50. So 2y squared equals 50. Divide both sides by 2. Y squared equals 25. Square root both sides. Y is going to equal plus or minus 5. So that tells us the y-intercepts are going to be at positive 5 and negative 5. We know most people cannot draw a perfect circle, but like Ms. Grody said, you just want to take a second and kind of outline the best circle you can. If you have a contractor from your old geometry class, feel free to use that. But remember, the basic concept is knowing that you have a circle right here of radius 5. Maybe to remind you, you might want to stick a radius in here and label it 5. Just so you know, the radius is 5. Domain. Leftmost point is at negative 5. Your rightmost point is at 5. So for the domain, I'm going to say, well, x is between negative 5 and 5. This compounded equality shows that. Negative 5 on the left, 5 on the right, and all the numbers in between. For the for the range, I'm going to start at the bottommost point, which is at y is negative 5. The highestmost point is at positive 5. So I'm going to say the range is from negative 5 to 5. If at any time during this video we go too fast, don't be afraid to pause it and to go back and listen to something that we said. So far, so good?
Sounds good. All right, so for example 2 here, we're going to not actually give you guys the graph. We're just going to ask you to write the equation of a circle. Now, the part that is important here is it says centered at 0, 0. Now, I don't know if you remember just up there at the top a little bit, I told you just general form of the equation of a circle is x squared plus y squared equals the radius squared. Now, you're going to see later in one of our other E units that we're going to shift the center of the circle off 0, 0, so that equation will look a little bit different, but it's the same basic concept. So what here we want to do is they're giving us the radius is 5, so I want to remember I've got x squared plus y squared equals the radius squared. So if the radius is 5, all I have to do is just remember to square that number right there. So we're going to get x squared plus y squared equals 25. And that's going to be your equation of a circle with that radius centered at 0, 0.
On the next example, we gave you the diameter instead of the radius just to see if you remembered that if you want to find the radius from the diameter being 12, the radius will be half of the 12, which is 6. We just wanted to see if you remembered that fact from geometry class. I'm going to follow the same procedure Ms. Grody said. General form is x squared plus y squared equals the radius squared. And now my radius is 6. And we do want you to finish this out. So 6 times 6 is 36. Your final answer is x squared plus y squared equals 36. That's your equation of a circle with radius 6 or diameter of 12. At this point, we're going to stop the video. We have to break this video into 2 parts. So remember, if you have any questions, feel free to ask a teacher during their office hours. We're here to help you understand these conic sections. So end of the first video. We're going to start the second video in a different module. Thank you.